Well, hello students. I'm going to work a few SAT problems. These come from the SAT practice tests in BlueBook from the latest group that were released. Those were practice tests 7, 8, 9, and 10. I believe this first problem comes from practice test number 7, and it says that if I have two functions f and g, and notice there is a b that is in the first function, it says if f and g are given and I multiply the two functions together and I get this, what is the value of the coefficient of b? Well, in this case, what I'm going to do is go ahead and multiply these two functions together and then see what we get. So there are my two functions. I'm going to go ahead and multiply these by distributing the x squared, and then I will take the bx and distribute that. And this is what I get for my four terms after I multiply these two functions together. Notice that you have to take care when you're distributing this bx that you get 9x squared times bx. And you can see I have a mistake here. This one actually is going to be 9bx to the third because I have x squared times x. And this one is actually supposed to be x squared. So this last term here is negative 27b x to the second power. The way that I'm going to figure out what the b coefficient is supposed to be is make the following comparison. I'm going to take this negative 27bx squared and compare it to what they said that we would get when we multiply these two functions. This would mean then that the negative 3x squared would have to perfectly match the negative 27bx squared. This is the only term that I have in my product that has the x squared term, and of course so is this one in the actual result of the multiplication. So therefore, what has to be true is that negative 3 has got to be equal to negative 27b, so b is therefore going to be negative 3 over negative 27, and that is a 1/9. That's my answer. Here's the next question. As you can see, this comes from the SAT practice test number 8. And question 19 says, which of the following expressions has a factor of x plus 2b where b is a positive integer constant? Well, one of the things that I'm going to do to solve this is realize that if you give me a polynomial and tell me one of its factors, what I know is that if x plus 2b is a factor, that means that if I set it equal to 0, negative 2b has got to be a 0 of the function. And that would mean then that if I took negative 2b and plugged it into the polynomial, I should get an answer of 0. So what I'm going to do is I'm going to try my answer A by plugging negative 2b in for x to see what happens when I set it equal to 0. Because remember, if that's a 0, and apparently it is because x plus 2b is supposed to be a factor, I should get 0. So here's what it would look like. All I've done at this point is taken the negative 2b and replaced the x's in the equation with the 0 of negative 2b. What I'm going to do now is I'm going to solve this for b, but remember what we're looking for here. We are looking for this to be equal to 0. Because when you plug a 0 into a function, you're supposed to get an answer of 0. Well, negative 2b to the second is positive 4b squared. So this gives me 12b squared. This is negative 14b plus 14b is equal to 0. Those two terms do cancel each other out. You're left with 12b squared is equal to 0, and the only solution that I get for b is a 0, and that doesn't meet the criteria that they gave us, where b is a positive integer constant. So that can't be the answer. I'm going to jump now to what turns out to be the correct answer here, and that's answer D. So what I'm going to do is I'm going to evaluate this expression by plugging in negative 2b for x. And there we go. So very similar to my answer in A, the only thing that's different is this middle term. So this is still 12b squared. This ends up being negative 98b plus 14b is equal to 0. Those last two terms, when I combine them, give me a negative 84b is equal to 0. When I solve this for b now and pull out a 12b, I get b minus 7, and 12 times b. So this gives me two values for b that are going to cause this to be an actual 0. That would be b equals 0 and b equals 7. That 7 is going to tell me that this is going to be my answer, because when I plugged in negative 2b and set this equal to 0, I did get b to be a positive integer constant, and that's the number 7. And so my answer is going to be D. If you want, you can go try the rest of those, and you'll see that when you stick the negative 2b in and solve for b, you will not get a positive integer for b. Okay, so and let me just show you one other thing that you could do on this problem. Another method is to use synthetic division. If that is a factor, then that means that if I were to divide by the 0, negative 2b, I expect to get a remainder of 0, if in fact it is a 0. So when you put these coefficients here, 3, 7, and 4b, and do synthetic division, you pull the 3 straight down, you multiply, you get negative 6b. If you add those, you get a 7 minus 6b, and then multiply by the negative 2b, which means you would distribute that right there. You would get negative 14b, and this was a 14b right here. You'd have a negative 14b plus 6b squared. When you add those two, all you get is the 6b squared, and then you would set that equal to 0 to solve for what b would be to make this remainder 0, and all you get is a 0, which is not a positive integer. So then if you did that with answer D, you would end up with the same expression that we did when we got our solution, and you'd set that remainder equal to 0, and you'd see that 7 would be one of the values of b that you would get. And so that would be your answer, D. All right, students, I hope that helps. I'll see you in the next video. Bye.